Welcome to topic 4503, Resilience Scenarios and Planning Strategies. This presentation explains how urban planners can move from broad resilience ideas to practical decision-making under uncertainty. The central question is not simply how a city can survive disturbance, but how it can prepare, adapt, and improve its capacity to deal with climate-related stress over time. To do that, we need to connect three levels of thinking. First, we need clear concepts: resilience, vulnerability, and adaptive capacity. Second, we need assessment tools that help us understand what is at risk, where weaknesses are concentrated, and what capacities already exist. Third, we need scenario methods that help planners act even when future conditions are uncertain, contested, and changing. Across the presentation, the emphasis stays on planning relevance, how to define problems, select indicators, build scenarios, and design strategies that are not only technically sound, but also equitable and adaptable. The presentation moves in a deliberate sequence from concepts to tools to action. We begin by asking why scenario thinking matters for resilience planning, especially in cities where multiple hazards, infrastructure interdependencies, and social inequalities interact. We then review the core concepts of resilience, vulnerability, and adaptive capacity so that later assessment and strategy work rests on a clear conceptual foundation. Next, we examine assessment frameworks, metrics, and indicators, including their role in climate-resilient land use planning. After that, we turn to scenario approaches such as exploratory scenarios, normative visions, strategic scenarios, and participatory backcasting. The final part focuses on planning responses, nature-based solutions, adaptive pathways, equity-centered decision-making, and case-based application. By the end, the aim is to show that resilience planning is most useful when assessment, scenarios, and strategy portfolios are treated as one connected workflow rather than separate technical exercises. This topic is structured around 5 official learning outcomes. The first is conceptual. You should be able to explain urban resilience, vulnerability, and adaptive capacity in a planning-friendly way. The second is analytical. You should be able to identify key resilience assessment frameworks and commonly used metrics. The third asks you to use basic indicators to assess vulnerability and adaptive capacity in an urban system. The fourth moves from diagnosis to design, requiring you to develop simple resilience scenarios and propose planning strategies. The fifth is attitudinal and strategic. It asks you to demonstrate awareness of why resilience-oriented thinking matters for sustainable urban development. These outcomes are cumulative. In other words, the topic is not only about knowing terms, but about using those terms to structure evidence, guide planning choices, and reflect critically on the wider purpose of resilience in urban policy and design. Scenario thinking matters because cities do not face a single isolated risk. Heat, flooding, drought, infrastructure failure, housing pressure, governance change, and social vulnerability can reinforce one another. Under these conditions, planning based on one expected future is often too fragile. Climate trajectories may shift, economic conditions may change, and institutional capacity may improve in some places while weakening in others. Scenario approaches help planners respond to this uncertainty without waiting for perfect information. Instead of asking which one forecast is correct, they ask how a strategy would perform across several plausible futures. In resilience planning, the objective is to identify robust and flexible responses, actions that still make sense across different circumstances, and options that can be adjusted when signals show that conditions are changing. In that sense, scenarios are tools for learning, testing, and strategic preparedness. For planning purposes, resilience, vulnerability, and adaptive capacity should be kept related but distinct. Resilience refers to the capacity of a system to absorb disturbance, recover, reorganize, and continue functioning while adapting over time. Vulnerability refers to the propensity to be harmed. It is often shaped by exposure to hazards, sensitivity to impacts, and limited capacity to cope. Adaptive capacity refers to the ability of people, institutions, infrastructure, and governance systems to adjust, learn, and respond. The relationship among these terms matters. A neighborhood may be highly exposed to heat, for example, but whether that becomes severe vulnerability depends on social and material conditions such as income, housing quality, green space, mobility, and access to cooling. Adaptive capacity is one of the main levers planners can strengthen through policy and design. This is why planning should not treat resilience as a vague slogan. It should translate these concepts into operational questions, measurable indicators, and actionable interventions. Urban resilience is a useful concept, but it also contains important tensions that planners need to recognize. One tension is between stability and transformation. In some cases, the goal is to maintain critical functions and recover quickly after a shock. In other cases, the better response is transformation, especially when existing urban systems are already inequitable or environmentally unsustainable. Another tension is between engineering views of resilience and broader social ecological technical perspectives. A drainage network can be resilient in one narrow technical sense, yet the wider urban system may still produce unequal outcomes or ecological harm. There is also a tension between specified resilience, which focuses on resilience to a defined hazard, and general resilience, which concerns wider adaptability to unforeseen disturbances. Finally, there is the tension between short-term shocks and long-term stresses. Good planning requires making these assumptions explicit, because different definitions lead to different metrics, priorities, and strategy choices. Assessment frameworks help planners structure complexity. They define the main dimensions that should be examined, such as governance, infrastructure, environment, health, economy, and social conditions. Metrics and indicators then translate these dimensions into observable evidence. Examples used in practice include broad city resilience frameworks, disaster risk reduction frameworks, and indicator systems such as ISO-based urban resilience standards. The important lesson is that frameworks and metrics are not neutral checklists. They shape what becomes visible in the planning process and what remains marginal. A good framework begins with the planning unit, the hazard profile, and the decision context. Only then should planners choose indicators. If the indicators are disconnected from actual choices, they become decorative rather than useful. If they are too aggregated, they may hide spatial inequalities and trade-offs. The most valuable metrics are those that support diagnosis, comparison over time, and strategy design, while remaining transparent enough that decision-makers understand what they represent. Climate-resilient land use planning depends heavily on indicator choice. One of the clearest messages from the topic evidence is that adaptation and mitigation require different, though sometimes overlapping, indicator sets. Mitigation indicators often focus on emissions, density, transport efficiency, and energy performance. Adaptation indicators may focus more on heat exposure, flood-prone land, surface permeability, ecosystem buffering, critical infrastructure sensitivity, or the distribution of vulnerable populations. Problems arise when mitigation metrics dominate the agenda so strongly that adaptation needs are underrepresented. A district may perform well on compact urban form, for example, while still lacking shade, drainage capacity, or accessible cooling spaces. For this reason, indicator selection should be tied directly to planning objectives. It should also make synergies and trade-offs visible. A land use strategy that supports transit and reduces emissions may still require supplementary adaptation measures. Good indicator practice therefore supports balanced decision-making rather than one-dimensional performance scoring. Nature-based solutions are especially important in resilience planning because they can address several objectives at once. Urban forests, wetlands, permeable surfaces, green roofs, retention landscapes, and river restoration measures can reduce heat stress, improve water management, support biodiversity, and enhance public well-being. Their appeal lies in these co-benefits, but their value should not be romanticized. Nature-based solutions are not automatically equitable, low-cost, or universally effective. Their performance depends on context, maintenance capacity, land availability, governance coordination, and long-term stewardship. They may also create uneven benefits if implemented primarily in already advantaged neighborhoods. For planners, the key point is that nature-based solutions should be treated as strategic components within broader resilience portfolios. They need to be linked to hazard analysis, land use priorities, and social inclusion goals. When used well, they can reduce risk and improve quality of life. When used poorly, they can become symbolic projects that do not adequately address the scale or geography of vulnerability. Scenario approaches are not all the same, and planners should choose them according to purpose. Exploratory scenarios ask what could happen under different external conditions such as stronger climate impacts, weak governance, rapid growth, or economic instability. They are useful for stress testing strategies. Normative scenarios ask what kind of future a city wants to create. They are value-laden and help clarify long-term goals. Strategic scenarios sit between these two modes by linking existing plans and policy commitments to future visions and concrete decision packages. Backcasting is closely related, but it has a distinctive logic. It starts from a desired future state and works backward to identify the steps needed to get there. The output of these methods is not just a story. Ideally, scenario work produces structured implications for land use, infrastructure, governance, and investment priorities. In resilience planning, the point is to create a bridge from uncertainty and aspiration to plausible, sequenced, and monitorable planning action. Strategic scenarios are especially useful when a city already has multiple adaptation plans, sector strategies, and policy commitments, but lacks a coherent long-term urban vision. In that situation, the challenge is not starting from zero. The challenge is integrating scattered policy intentions into a future-oriented planning framework. Strategic scenario work typically begins by scanning existing documents and current plans. It then uses participatory processes to identify shared aspirations, tensions, and spatial priorities. From there, the city can build a set of alternative future pathways that reveal how today's choices may shape tomorrow's urban form and resilience performance. This approach is valuable because it makes planning cumulative and directional. Instead of treating each measure as an isolated intervention, it asks whether present actions are actually moving the city toward a desirable future. It also creates a basis for selecting indicators, milestones, and responsibilities so that long-term visions remain connected to implementation rather than remaining abstract statements. Participatory backcasting adds an important democratic and strategic dimension to resilience planning. Rather than projecting trends forward, the method starts with a target year vision, such as a district that is safer, cooler, greener, and more socially inclusive by 2040 or 2050. Participants then work backward to identify the major actions, institutional changes, investments, and collaborations required to reach that future. This method is useful when the goal is transformational change rather than incremental adjustment. The topic case evidence also shows that process quality matters. Participation should not be tokenistic. It needs to include relevant actors, create space for knowledge exchange, and produce outputs that can actually be used in planning. A useful backcasting exercise should generate more than broad aspirations. It should identify milestones, responsibilities, and decision points. In this way, backcasting helps cities convert a desirable long-term vision into a practical sequence of actions that can begin under present conditions. Adaptive pathways extend scenario thinking by treating planning as a sequence of contingent decisions rather than a single fixed master plan. This is valuable under deep uncertainty, because no city can know in advance exactly when thresholds will be crossed or which combinations of hazards will become most severe. In a pathway approach, planners identify an initial package of actions that makes sense now, but they also define alternative branches that can be activated later. These branches are linked to trigger points, such as repeated overheating in vulnerable districts, drainage failure under certain rainfall intensities, or evidence that social protection measures are not reaching at-risk groups. Monitoring then becomes central, because indicators help determine when a shift is needed. The benefit of this approach is that it avoids lock-in. Instead of overcommitting to one long-term strategy, the city maintains flexibility while still taking action. Adaptive pathways therefore connect assessment, strategy design, and learning in a practical planning sequence. Equity is central to resilience planning because climate impacts are not experienced evenly. Some groups have fewer resources, weaker representation, more hazardous living conditions, or less access to protective infrastructure and services. Equitable resilience asks not only whether a city becomes safer overall, but also who is recognized, who participates, and who benefits or bears costs. These concerns are often described through three dimensions. Recognitional equity means acknowledging different needs, identities, histories, and forms of vulnerability. Procedural equity concerns participation and influence in planning and decision-making. Distributional equity concerns how benefits, protections, costs, and burdens are spatially and socially allocated. A strategy that lowers average risk but displaces vulnerable residents or excludes them from decision-making cannot be treated as fully successful. For this reason, equity should be embedded from the beginning of scenario building, indicator selection, and strategy design. It is not an optional adjustment at the end, but a criterion for both legitimacy and effectiveness. The Barcelona and Berlin case material helps show how equitable resilience enters planning practice. Both cities have engaged seriously with climate adaptation and broader sustainability agendas, and both display forms of policy learning and innovation. At the same time, the comparison shows that equity language alone does not guarantee equitable implementation. In practice, recognitional, procedural, and distributional questions remain unevenly addressed. There may be ambitious strategic documents, but weaker translation into local implementation, monitoring, or accountability. There may also be participation processes that are formally open, but still uneven, in whose knowledge is recognized and whose priorities shape final decisions. This is why the case evidence is useful for teaching. It shows that resilience planning is not only about identifying technical measures. It is also about governance quality, conceptual clarity, and follow-through. Cities can be progressive in discourse and still struggle to ensure that adaptation strategies consistently benefit vulnerable communities across neighborhoods and policy sectors. Once planners have indicators, scenario logic, and an equity lens, they can begin building strategy portfolios. A portfolio approach recognizes that no single measure is enough. Instead, strategies are combined into packages that fit different future conditions. One scenario may call for moderate investment in cooling infrastructure and targeted greening. Another may require more extensive land use restrictions, water-sensitive design, and social support systems because hazard intensity and vulnerability are both rising. In every case, strategy portfolios should blend spatial measures, ecological measures, governance measures, and social measures. They should also be stress-tested for trade-offs and feasibility. For example, an ambitious green redevelopment program may improve heat resilience, but it may also increase land values and create displacement pressure unless safeguards are built in. Indicator-informed planning is especially useful here. It allows planners to compare packages, identify who gains and who may be burdened, and choose actions that are both robust and justifiable. The overall workflow in this topic can be summarized as assessment, scenarios, pathways, and iteration. First, define the system, hazards, spatial scale, and stakeholders. Second, develop a baseline using indicators that capture exposure, vulnerability, and adaptive capacity. Third, choose a framework and metrics that match the decisions being made. Fourth, build scenarios, using exploratory, normative, or strategic approaches depending on the planning task. Fifth, convert the scenario outputs into strategy packages and adaptive pathways with clear milestones and trigger points. Sixth, apply an equity check so that benefits, burdens, participation, and visibility are examined explicitly. Finally, implement, monitor, and revise. This last step matters because resilience planning is never finished once a document is approved. Conditions change, knowledge improves, and institutions learn. A good resilience strategy is therefore not static. It is an evidence-based, monitored, and revisable process that links planning diagnosis to long-term adaptive governance. Across the topic materials, several best practices appear consistently. Indicator choice should be tied to planning objectives rather than selected because data happen to be available. Adaptation and mitigation should be treated together where possible, but their trade-offs should be made explicit rather than assumed away. Participation needs to be meaningful, especially when strategies affect vulnerable communities. Scenario work should produce actionable outputs such as packages, milestones, responsibilities, and monitoring plans. Finally, resilience planning should be revisited regularly instead of being treated as a one-time exercise. The common pitfalls are just as instructive. One is reliance on a single expected future. Another is token participation that creates legitimacy on paper without real influence. A further pitfall is equity blindness, where overall improvement hides unequal outcomes. There is also the problem of weak implementation logic. If no triggers, responsibilities, or monitoring arrangements are defined, even well-designed scenarios may not improve planning practice. The mini exercise in this topic brings the method together in a simple applied format. Imagine a district exposed to both extreme heat and flash flooding. The task is to write a short resilience vision for 2040, choose a compact set of indicators, define 2 scenario axes, and propose a 3-step pathway from the short term to the long term. The value of the exercise lies in disciplined simplification. Students must choose indicators that matter, not everything that could be measured. They must select scenario axes that reflect genuine uncertainty, such as climate intensity, governance capacity, or fiscal capability. They must propose pathway steps that are realistic, sequenced, and linked to triggers. And they must add at least one equity check: who benefits, who may be burdened, and whose needs still remain invisible. This is a useful teaching format because it moves quickly from theory to planning judgment without requiring a full-scale technical model. The main takeaway from topic 4503 is that resilience planning works best when it links concepts, indicators, scenarios, strategies, and equity in one coherent process. Resilience, vulnerability, and adaptive capacity provide the conceptual base. Frameworks and indicators make those concepts measurable in specific places. Scenario approaches help planners think beyond one forecast and act under uncertainty. Backcasting and adaptive pathways then help convert visions into sequenced decisions, while monitoring keeps those decisions responsive over time. Nature-based solutions show how ecological approaches can support resilience, but they must be implemented with attention to context, governance, and fairness. The case evidence reminds us that adaptation planning is also institutional and political. A city becomes more resilient not simply by adding projects, but by learning how to make better, more flexible, and more equitable planning decisions across changing futures.